Alright, so this video is going to deal with writing proofs, dealing with segment relationships. So we're going to use what we talked about in the previous section and go from there. Now, postulates and theorems. First, what's the difference between a postulate and a theorem? Well, a postulate is simply a statement that we accept without proof, whereas a theorem is a statement that we need to actually prove. We use both of them throughout the year with our proofs. We'll just always prove our theorems. Postulates we will just accept. For example, the segment addition postulate we will not prove. It says if A and B and C are collinear, and point B is between A and C, if and only if AB plus BC equals AC. We're going to use this to be able to state that we can add together two smaller pieces of line to equal a larger piece. We're going to use this concept throughout the proofs we're going to write today. So let me first pause the video to draw a diagram and give the given statements. Alright, so here's our first proof. So we have this diagram. We are given that AE and BE are the same length, they're congruent. DE and C are both also the same length, they're congruent. We need to prove the large piece is AC, and BD must then be the same. So one of the ways to write our proofs, and the way I'll write it in all our videos, is a two-column proof method. Where the top left we make our T-chart, top left is the statements, top right is your reasons. First statement does not have to always be this, but it generally works out like this. It should be the given statements. So we write our given statement, AE congruent to BE, and DE congruent to CE. Reason, it's given. Now, we need to find some way to bring AC and BD into this problem and relate it to the given statements. Well, AC is made up of two smaller pieces, AE and EC. So I can say AE plus EC equals AC. The same logic can tell me that DE and BE, DE plus EB equals BD. That's our segment addition postulates. Now we've brought AC and BD into the problem, we need to find some way to we need to get them to be equal to each other. So we need to find some way to make these left-hand sides be the exact same expressions. Well, let's go back to the given statement. We're told that AE is the same thing as BE. So if two things are the same, I can replace them in my equations. So I can replace AE in this equation with BE. I can also replace EC with DE, since CE, even though it's a different letter order, it's the exact same line, CE and DE are the same. So all I've done is I've replaced equal pieces. AE and BE are the same, so AE becomes BE. EC and DE are the same, so EC becomes DE, and that has to equal AC. When we replace equal pieces, this is called substitution. And then finally, well, if we take a look at this last piece of statement 2 and this piece in statement 3, DE, DE, BE, BE. I'm adding the same two pieces together, so the left-hand sides are both the same. If the lefts are the same, the rights must be the same. So AC is congruent to BD. That is also our substitution property, which we can abbreviate as just sub. There's our first proof. Okay. Let's take a look at another one. So let me draw the diagram for this one and get right at the given statement. Alright, so here's our first proof. Well, second proof, sorry. We have this line AD with points B and C on the line. We're given that the length of AC is the same as the length of BD. We want to use that to prove that AB and CD must also be the same lengths. So we have our given statement first. Now, similar concept to the previous problem. I need to find some way to bring AB and CD into the problem and have them related to my given statements. Well, the only way that AB is related to AC is if I use my segment addition postulates. So AB plus BC is equal to AC. The same token, BC and CD have to add to be BD. That's our segment addition postulates. There's our abbreviation, seg, add, post. Well, in our given statement, we're told that AC and BD are the same. Since the right-hand sides are equal, the left-hand sides must be equal. So I can see AB plus BC must equal BC plus CD. All I did was just simply substitute in equal pieces. Right sides are the same, therefore the left sides must be the same. And now if you notice in this equation in step 3, BC's are on both left and right hand sides. So they will subtract out, leaving just AB congruent to CD. That's our subtraction. You can abbreviate it SUBT for subtraction, or you can write it out. One quick thing with my notation, every teacher is different. Equal and congruent, they're technically different, but they're pretty much the same. So since they're essentially the same, I don't distinguish between the two of them in my proofs. So you can just use them interchangeably. It's no big deal. Some teachers will require you to say AC equal to BD first because they're congruent, AB equals CD first, and then say AB congruent to CD. It's an unnecessary step. It doesn't help in any way the understanding, so that's why I don't include that process here. Alright, so there's the second proof. Alright, so let me draw the diagram for this one. Alright, so for this one it looks very similar, but now it's the opposite proof. We're now going to start with the fact that AB and CD are congruent, and that's what those tick marks means if you haven't quite realized it yet, congruent segments. Use that to prove that the pieces, the overlapping pieces, AC and BD, must also be the same. So again, we start with our given statements. And like with everything else, we need to find some way to bring AC into the problem, relate it back to the given statement. So in order to do that, we use our, again, segment addition. AB plus BC equals AC. BC plus CD equals BD. Those are all our segment addition postulates. Now, this should be very similar to our very first proof we did. We notice I need to find AC and BD to be the same. So since I need to have the right-hand side the same, I must show the left-hand sides are the same. I already got BC's, so I need to make AB and CD the same. Well, since they're congruent, I can just rewrite AB in the first problem with CD. So that becomes CD plus BC equals AC. By just simply substituting in equal segment CD for AB. Well, now I notice my left-hand sides are both the same, therefore my right-hand sides, AC congruent to BD, must also be the same. As again, also our substitution property. Alright, so there's our third proof. We got one more to work on. So again, I'll pause so I can draw the diagram. Alright, so we have this proof. So we're told that X is the midpoint of WY, Z is the midpoint of VY, and that XY is congruent to YZ. We're going to prove that the WX and VZ pieces are also the same. Now, one thing I will allow, if you only have one given statement, I need you to write the entire thing. You can't be that lazy. But if you have multiple given statements going on, for my class at least, you can go ahead and just write givens for the statement. Reason is given. Now, for those of you who are not in my class, your teacher will probably not let you do that, so make sure you write out the whole given statement. Now, well, the question is, what does it mean to be a midpoint? Well, a midpoint means that we have two congruent pieces. So WX is congruent to XY, and that VZ is congruent to YZ. That's our midpoint theorem. Well, now I have the congruence. Well, the given statement told me that WX is congruent to YZ, which I can replace, XY, sorry. I can replace the XY with our YZ. So WX is congruent to now YZ. That's our substitution property. And that's great because now since I have both WX and VZ congruent to the same piece YZ, that means they must technically be congruent to each other. Also our substitution property. Now, don't assume, because I mean most of the proofs we've had substitution be the last step, don't assume that's always going to be true. A lot of times that's not going to be the last step, so don't fall into that trap. Okay, so this is the intro to proofs. We're going to do angle proofs next, and then we're going to do a lot more proofs as we move on through the chapters. So make sure you ask questions. Take care.